Apologize about that. Um, I'm gonna just my okay, yeah, everything's working. Sorry about the interruptions, and just gonna go right back into the lesson. And um, basically, last time we talked about the various types of ICMP messages that you can send out, right? We talked about how you could send out echoes and replies, but we also mentioned that there were different various types of ICMP messages, right? We talked about that there's a type 13 for timestamp. We obviously know the type 0 for echo and the echo reply, and then number 8, type 8 for echo. And there's some other ones that are pretty useful, and then there's a lot of deprecated ones. Um, So we talked about the various types of ICMPs. We talked about what ARP was and the ARP protocol. We talked about, um, let's say, my computer, right? Computer one, my computer one. I know the logical address of computer three, but I don't have the MAC address. So what my computer one would do, it would send out an ARP broadcast, right? ARP messages are broadcasts, and it would broadcast out to the network who has the IP address of blah 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 blah. And let's say that's computer three's IP address. Computer 3 would reply with an ARP reply, and it would say that's me, and it would provide it its own MAC address, just like that. So we talked about on last Sunday, or not last Sunday, last Saturday, the um, the tool Nmap, and a lot of people know Nmap, but people believe Nmap only know Nmap for its port scanning capabilities. Um, Nmap is a very, very powerful tool, especially if you know how to use it correctly. Nmap can actually use ARP messages, ICMP messages, and even TCP messages to discover live hosts on a local network. And on last Saturday, um, or I yeah, I think it was Saturday. Yeah, that literally the past Saturday where I talked about ARP and Nmap being with ARP, but it really wasn't the quality of content that I wanted to put out. So I'm gonna go over this module one more time, this lab one more time, and then we'll also get into ICMP. And so it's gonna be a double header today. I know it's gonna be a little bit of a long one, but I think it's gonna be really good. Um, so there, we talked about ARP, and then we also mentioned um, that with ARP you can use Nmap, right, to discover live hosts. But there's something that we forgot. I guess I didn't really emphasize was there are two types of users in Linux, or yeah, with Linux. There are privileged users and then there are unprivileged users. And the privileged users are pretty much um, going to be your root user or people who belong in the sudo group, right? So if I ID myself, you can see that I'm going to be in the sudo group, right? Meaning that I have privileged users abilities. Um, and if you don't have the sudo group ID, then you're going to have unprivileged users abilities. And it's important to know this because with Nmap, depending on your status of whether you're privileged or unprivileged is going to determine what kind of messages and types of searches you can use with Nmap. As we can see, if you're a privileged user, you can use ARP requests, um, and you can even also send ICMP echo requests. You can send TCP ACK requests, and you can even send in TCP SYN requests, and also timestamp requests with ICMP. Um, Again, you can only do these types of packets. You can only send out these kind of packets if you belong in the privileged user group, right? If you're unprivileged user, you're going to, no matter what, if you scan targets outside the local network, no matter what, you're always going to complete a TCP three-way handshake. You're always going to do a TCP three-way handshake. There's just no way getting around that, right? So it's again very, very important when you use Nmap to always preface it with the sudo, right? Because if you don't use sudo, you're and again, this is local network when you use ARP, right? Because ARP is only good for local networks, right? Because what do we say? If it's outside of its local network, where does it have to go? It has to, if it's anything outside of its local network, it always has to go to the router. And we know that ARP is a broadcast. And what do we know that default gateways do? They always drop the broadcast. They never let the broadcast message leak, right? So ARP is only good for the local network. Um, Ping is a layer 3, so you can use ping to try to interact with machines outside of your network, right? Um, so if you wanted to, like if you're in a local coffee shop, right? Like let's say I'm in a local coffee shop, right? I'm at this coffee shop. I'm using their guest Wi-Fi. If I typed in sudo nmap PRSN, and I typed in, let's say this is the IP address of the network, it would it would send out an ARP request to all IP addresses in the 24 network, right? So meaning there's going to be 254 users, 254 possible IP addresses that can be assigned by the DHCP server to guests in this network, right? Unless they configured it and reserved certain IP addresses, but it's going to scan every single one of those 192.168.1.1 all the way to 254, right? And whoever is taking those addresses, um, if there are live hosts that's using that address, it's going to reply with an ARP reply, right? So basically, this is basically what would happen if I typed in this nmap PRSM 192.168 blah blah blah. My computer would send out an ARP request, and any hosts that are live on this local network is going to reply with an ARP reply, and it's going to provide the MAC address of that machine. So if we were to look at this through Wireshark, right? If for whatever reason we were packet analyzing the network, and if I'm a cybersecurity analyst and I'm seeing this, just a flood of ARPs who has, 1010, 210.1, 210.2, 210.3, like if I saw this kind of activity, and that should raise some alerts. That should raise some alarm, right? Like that's not normal, typical behavior. Um, so that could be a indicator that somebody is in the network and they're doing something they possibly shouldn't be doing, right? And then there's another tool called ARPScan. Basically, pretty much the same thing as the Nmap PR. right? Um, so it would be ARP scan, and then you can either type in the dash L to indicate the local network, or you can even specify the interface, right? So meaning, like, let's say, for example, I have multiple interfaces, right? I have this ETH0, I have the loopback, I have this tune zero. I think that's the um, the bridged adapter, I believe. I'm not 200%. I'm not too like 100% certain, but I know that this is another interface running on a private, allowing me. It's pretty much a private VPN that's allowing me to talk to the TriHackMe network, right? So I could indicate to ARP which interface I wanted to ARP scan, right? And this is the syntax sudo ARP scan whatever the network address is, and it's pretty much going to give you the IP address. Whoever's so there was someone use there's a device using the 1010 to 1075 IP address, and then they have this MAC address of 0283 blah 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 blah. And sometimes Nmap will also do something called a reverse DNS lookup, meaning it'll try to also find out the name of the device, right? So if you name your device, I don't know, like for me, I think my phone's name is Moses's um, Samsung phone, right? Um, that would pull up in the reverse DNS lookup. So again, if we were security analysts, packet analyzing, packet sniffing, and somebody ran this Nmap, or I'm sorry, somebody ran this ARP scan. Let's say they ran ARP scan, sudo ARP scan 1010 210.6, and we were analyzing the network, and we would pretty much see this, right? We would see all these ARP requests. And again, as a cybersecurity analyst, this is um, not normal behavior. So this should be raising red flags. This should be an indicator of somebody's doing some suspicious activity, right? Because again, you're not gonna. This is not typical to see ARP floods like this. So yeah, uh, not normal to see ARP requests like that, but the purpose again was the purpose of using ARP with Nmap is to discover live hosts on the local network, right? You can discover live hosts without having to ping, without having to port scan or TCP. Like you can keep it pretty anonymous with just with just taking an ARP reply or an ARP request and just sending that out, flooding it out, broadcasting out to the network, and seeing who's on the network. Right. That's a great step um, in ethical hacking and penetration testing. You know, using this kind of scan is going to give you um, a really good mapping of your target. Right. Obviously, the bigger the target, the more information, and you got to be able to parse through and pretty much determine what's important, what isn't. And I mean, again, like if you're scanning a network that has over 1,000 employees and you're trying to look for particular employees, it's kind of hard. But again, this is a great starting point, right? It's the beginning. Um, it's the beginning of like I would say this is kind of like the beginning steps, right, of your penetration testing. Trying to enumerate your target, trying to find out information without really having to do too much work. So ARP, great way to discover people on the local network. Um, and another way to do so is through ping. And we talked about this was like several weeks ago, right? We talked about several weeks ago how usually firewalls are configured to block ping echoes, right? And this is like network admins, they just don't. There's a lot of things that could go possibly wrong if you allowed echoes. So they network admins will usually configure firewall rules to just block and deny those kind of queries, right? Um, and so here's the syntax that they want you to use if you want to use an ICMP echo request. It's the PE flag. And remember, if you don't want your Nmap to do a port scan following after the echo request or the ARP request, just type in the SN flag, and that's just going to cancel the port scan. And so um, I tried this on my Ubuntu machine, so it should work. My Wireshark should be able to pick this up. Um, so let me get Wireshark up and running. Sudo Wireshark. Put an ampersand to just put that job in the background. And my Wireshark should be running. Okay, cool. So here's my Wireshark, and it's already scanning. So let me stop that. Let me go ahead and filter out for just pings, and I want to start a new one. Okay, so we have my Wireshark running, and it's only filtering out for pings, right? So let's say I'm in a coffee shop, and I know that this is the 192.168.1 network, right? So I would do sudo nmap, uh, type in PE for ping echo, type in SN to not don't do not scan, do not do a port scan, and let's say yeah, we're on the 192.168.1 network. So yeah, let's run this and let's look at my Ubuntu machine, and it should get an echo. Nothing yet. Interesting. Even though we were able to uh, okay, so the ping is obviously working because my Wireshark is capturing that. Um, Now I wonder if let's see, to use ICMP echo request to discover live hosts, as shown in the figure. An ICMP echo scan works by sending a echo requests and expects the target to reply with the echo reply. So it could be possible that again, actually, it's funny. I don't know that's why it's not working because we were clearly able to um, we were clearly able to get echo. We were able to get pings by my Kali machine. So let me filter out this way. So now we're just gonna filter out specifically for my machine. as you can see, my machine is talking to the Try Hack Me network um, through the OpenVPN. Um, Actually, you know what? How about we do source IP address. Let's see, IP address. I think it's gonna be ICMP. Okay, let's just filter this out for ICMPs. Let's try one more time. Um, Not sure why it did not. Okay, so that wasn't it. That was my router sending out a routing advertisement. Hmm. It could be possible that my firewall on my Ubuntu could be possibly blocking it. But again, we were able to ping it directly, so I'm not sure exactly what the underlying issue is. But um, but as you saw with the Nmap scan itself, you were able to see that I was able to pull up something similar to this, right? I was able to pull up something similar to this where it was telling me there's a host up at this specific address, and here's its MAC address information as well. Um, and if we were able to capture that on the Wireshark, we would be able to see all these ICMP echoes, right? We would pretty much be able to see all these echo requests. Um, and so that's with echo requests, right? We're able to send it with echo requests. And we mentioned how firewalls are configured to block echo requests, right? Well, sometimes, again, like I said, they're only configured to block ICMP echo requests. Sometimes you can actually bypass that and send timestamp requests, right? ICMP type 13 messages. And uh, and again, if the firewall isn't configured properly, you can actually bypass that ICMP block request by sending a different and crafting a different type of ICMP message, right? So I could send a timestamp request, and if there's a host live there, it'll reply with a timestamp reply. Again, the purpose of this is to discover live hosts, right? This is the purpose of this, right? And knowing that there's someone or something on the network is very, very useful, especially in the beginning of your enumeration process, right? So if I wanted to send out a Nmap ping timestamp request, this would be the syntax: Nmap dash capital P P, and then again the SN to indicate we do not want a port scan. So the syntax would look like sudo nmap capital PP SN, the target network, and if those machines are up and running, and if we had a Wireshark packet analyzer, this is exactly what we would see, right? So do you see the difference? The PE flag stands for ping echo. So when you packet analyze, you're going to see echo requests. But if you sent a PP flag standing for timestamp requests, you're going to see the in the information header timestamp requests. And again, if the firewall isn't properly configured, this is an easy bypass. And this is how you're able to discover live hosts on the network, right? Um, so this is a great tool, or great. This is good. This is knowledge you want to know, especially when you're out in the field trying to, again, conduct your basic mapping of the network and trying to get a good idea of how many users are on this network. This is a great way to do so. And finally, there's one more that they teach us, and the this is called the mask query, right? And this is going to check whether it gets an address mask reply, right? So again, the importance of this is not the it's really not the ICMP message itself. It's using different kinds of ICMP messages to bypass firewall rules and see if you can find and discover live hosts on the network, on the local network, right? So again, if you want it, so previously we used PP to send out a timestamp request, and then prior to that we used the PE flag to send out a ping echo to send a address mask query. You're going to send in the PM flag, right? So the nice thing about this is they all kind of make sense, right? Like ping echo PE PP. I wish that this could be a little bit more relative, but timestamp request with the PP, and if you want to do a mask query, uh, ping mask. That's how I see it with the PM. And again, one more time, we run the SN flag again to indicate that we do not want to run a port scan, right? And if you ran this on your network, this should be the flag sudo nmap pmsn and your target network. If you were to run a Wireshark packet sniffer, this is what you would see. ICMP address mask requests. And again, as an analyst, as a cybersecurity analyst, if you're analyzing um, network traffic and you start all of a sudden seeing ICMP floods like this is a big indicator that there's someone in your network that's doing something fishy, right? Again, this is not normal behavior, right? Um, Let me get my other machine up, right? Because like when you're on when you're on an um, enterprise level network, I mean, dude, like this is going to be flooding, right? Um, I mean, I mean, like this is going like like just floods of data and you need to learn and establish a baseline of your network, right? And that's going to come along with working and experience, right? Because you can't establish a network baseline if you don't work there, right? And if you haven't been um, there to pretty much create profiles for the networks and understand what's normal behavior and what isn't. But pretty much, this is exactly what you would want to see, right? Is like um, just this is kind of just basically normal traffic, right? And then all of a sudden, you start like, let's say I'm on your network, right? And you're the security analyst and, you're just like, oh yeah, you're just looking at, oh, look, who's the 192.168.1220? What, he's got this open VPN. Okay, that's cool. You're just doing your job, and then all of a sudden, let's say, me, I'm a threat actor. I'm in your network, right? And I just wanna mess around and I just wanna mess around and see what's going on. Uh, just play. Let's just say I want to play a prank on your network, right? Let me just confirm. This is the 216. Okay. Okay. So, you know, bam. Let's say I'm on your network and I decided, you know what? I just want to have a little bit of fun and I'm just gonna just DOS the network. Let me just DOS the network, right? And obviously this isn't going to be a crazy effective uh, DOS, but bu- 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 you see all this? Like again, if you're a security analyst and you're just like going through your day, like, oh yeah, this looks all normal. Yep, yep, yep. Just going through, normal packets. Everything seems okay. You just, yeah, this looks okay. And then, bam, you get hit with all these ICMP requests. This is going to this should be very alarming, right? Like, and as you can see, this is still going. And as you can see, um, my machine is replying to all of these pings. And I should really configure my firewall to not do that. But I'm gonna go ahead and stop this. And I introduced this tool a little while ago, but this is the HPing 3 tool. And with this, you can pretty much spoof your own IP address. And yeah, you can create different kinds of syntaxes to do different kinds of jobs. But yeah, um, I could spoof my IP address and do this, and you would have no idea, right? Like, how would you know it's me? Like, again, going through back into this packet analyzer with Wireshark. I mean, if you were a if you were a analyst, like, how are you supposed to go through this, right? Um, you go through this and you see that let's say let's do let's do da, 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 da. I mean, how would you be able to, like, would you be able to filter through this, right? And not only filter through it, but like you're trying to figure out, okay, who's the threat actor in this situation. I mean, good luck, because I just spoofed my IP address, right, with the random source flag. So there's no way you're gonna find who I am, right? So um, that was just with HPing 3, right? I could do that with Nmap as well. I could spoof my Nmap, and that way you wouldn't know that this was me. Um, I want to save this. I know that this is the last portion of it, but it's a pretty long one, and because I double upped on the ARP and the ICMP, I feel like there's a lot of information that that could that needs to be digested. And again, I don't want to just put out and just vomit all this content. Um, I'd rather just take it slow and break it down. And so that's all I have planned for today. Next time I stream, which will probably most likely be tomorrow, we'll go over the TCP UDP with Nmap, and then we'll get right back into hopefully I can get into Neticat. Yep. Finally my Uh, Proxy is letting me go through, but the tomorrow I would like to finish with this Nmap lab and pretty much cover the TCP UDP aspect, and then after that I would like to. I'm definitely not French. I would like to get right back into the actual material, because uh, what we're gonna cover next is pretty darn important. If I remember correctly, it would be chapter. I want to say we left off at chapter 8, chapter 9, chapter 8, chapter 9. We'll find out momentarily. Da da da. So yeah, we left off at chapter 8, and this was we talked about okay, so actually we're gonna get to chapter 8. We stopped at chapter 7. That's right. So we stopped at chapter 7. We talked about routers, the routing table. We talked about, remember, this is, this is a little bit while ago. So go back to the older videos and refresh your memory if you have to. But we talked about how routers talk to other routers and share each other's routing tables in order to, pretty much update automatically so that when the messages are going out, the routers know, okay, this is the best way for me to get this packet message to the final destination, right? So go back and refresh your memory if you need to. Chapter 8 is going to be a pretty heavy lecture chapter. We're going to be talking about IPv4. We're going to be talking about um, this is kind of this is a little bit of the hard stuff. We're going to be talking about binaries to decimals, right? This is pretty much how computers speak language, right? They don't talk like us in like human languages. They talk in binary, zeros and ones. So this is going to be a pretty heavy chapter, and I don't know if I want to go through an entire chapter of this, because again, when we get into the binary aspect and then try to understand logical anding and things like this can get pretty tricky. So um, I'm going to do my best to navigate us through this chapter. I expect us to start this chapter on Wednesday. Again, finish this uh, try hack me exercise in lab tomorrow. But yeah, thank you guys so much for stopping by and watching. As always, appreciate all the support, and I hope to see you guys very, very soon. And until then, take care and love you guys. Bye.